Alright, I'm going to show you guys how to do compound inequalities. So far, what you guys have learned have only been simple inequalities. But sometimes you're going to have two inequalities that are combined, and you're going to sometimes see the word and you're going to sometimes see the word or. If you have this situation, you're dealing with a compound inequality. Alright, so let's look at how to graph these. Right here, if you see that very first line, you've got an and inequality. They are either written separately as two separate inequalities joined by the word and, or you can combine and inequalities into one statement. Let's talk about how you would graph these. First thing is, let's just assume 2 is here and 6 is here. It says x is greater than 2. I'm going to have an open circle, and my arrow is going to go to the left. Excuse me, to the right. If x is greater than, x is less than 6, then I'm going to have an open circle, and my arrow is going to go to the left. Now, if it's and, we need the solutions to be in that section where x is greater than 2 and less than 6. So I'm going to highlight where your solution region would be. It would only be this part that I'm coloring red that is between the 2 and the 6. So a solution like -1 or 1 or 0 would not be in the solution to the compound inequality, or a solution like x equals 6 or 7 would also not be in the solution to the compound inequality. Only those points that lie in the red region would be solutions to the compound inequality. The only thing different on that second line is instead of having open circles, we have closed circles, but again, your solution is in between. Now the other type of inequality, compound inequality, that you're going to see is an or compound inequality. That means that the solution can lie in the solution region for either the first inequality or the second inequality. It doesn't have to lie in both. So let's draw 2 and 6 again. Our circles are open. Now x is less than 2 is going to go to the left, and x is greater than 6 is going to go to the right. So that means that any number in either one of the solution regions will work. So if x is, let's say x is 1, that's okay. Or x is -1, that's okay. Or x is -10, that would be okay. If x is 8, that's okay. Or 9, that's okay. It doesn't have to lie in the overlapping region, only one or the other. Where it could not lie would be anywhere from 2 to 6, where there's no arrow drawn. The bottom one, the only difference is that we've got a less than or equal to and a greater than or equal to, so it'll be exactly the same solution, except now 2 and 6 are included in the solution. Okay, so we're going to do a chemistry application. I'll read it for you guys. A water analyst recommends that the pH level of a swimming pool water be between 7.2 and 7.6 inclusive. That word inclusive is key. Write a compound inequality to show the pH levels that are within the recommended range. Graph the solutions. So we know we're going to have some numbers between 7.2 and 7.6. Now when it says inclusive, what that tells us is that the pH can be exactly 7.2 and it can be exactly 7.6. Now let's ask ourselves, just like I've done in the other inequalities, can the pH, which we'll call P, can it be 7.3? Yes, it can. Can it be 7.4? Yes, it can. Can it be 7.56? Sure. Can it be 7.32? Yes. So where our solution region is that part right between the 2 points. Now let's write the inequality for it. This first inequality is P is greater than or equal to 7.2. The second one is P is less than or equal to 7.6. Okay, so we can write it like this and put an and between it. But most of the time what you're going to see is you're going to see the P in the middle, the smaller number on the left, the bigger number on the right, and then the big fish stays the big fish no matter where it goes. So on this top part, P is the bigger fish. All that this is going to talk about here is what it's called. Right here it says that the overlapping region, whoops, I didn't mean to mark it out, I meant to underline it. Overlapping region, that's the solution to an and compound inequality. The overlapping region is called the intersection. Let me write it over here so you can see it better. It's called the intersection. So let's talk about how you solve compound inequalities. We saw how to graph them, but now let's talk about how to solve them. If you look down at example A, you see something that might look a little bit confusing to you. This is what you need to do with it, is you need to kind of separate it out. Right now it's been lumped together. We're going to separate it out into two different inequalities that we can solve. So this inequality is going to be x plus 2 is less than or equal to 8. Then the other inequality is going to be 4 is less than or equal to x plus 2. And then we solve. Solve like we always have. Draw your brick wall, subtract 2 from both sides, and we end up with 2 is less than or equal to x. And on the other side, also subtract 2 from both sides, and you're going to have x is less than or equal to 6. If we were to graph those solutions, don't have a whole lot of room, what you'll see is on the orange part, we've got, if 6 is right here, our circle is closed, our arrow goes to the left. On the green part, let's say 2 is right here, our circle is closed, our arrow goes to the right. The solution region is only this part where there's both orange and green. So a number like 2.1 would be okay, but a number like 1 would not. A number like 5.3 would be okay, but a number above 6 would not. So that's how you're going to graph it. The next one, again, we're going to separate it out into its pieces. So this is going to be 2x plus 3 is less than 9. And the other side will be negative 5 is less than or equal to 2x plus 3. And then solve like you always have. Draw your brick wall. On this one we're going to do subtract 3 from both sides. Then we'll have 2x is less than 6. Divide both sides by 2. And we get x is less than 3. The other side, do the exact same process. Subtract 3 from both sides. You get negative 8 is less than or equal to 2x. Divide both sides by 2. And you're going to get negative 4 is less than or equal to x. Then graph your solutions, and you got it. Alright, so now our next one. Sometimes you're going to have or inequalities. The answer is going to be in the solution region for either of them. The solution is in one of them or the other. It doesn't have to be the overlapping region. It's going to be the region that's called the union. Union means like put things together. So the solution can be in one or the other put together. So let's do one of these. Now these are nice because they've already been separated out for you. So all you have to do is solve them. We want to get a by itself by adding 4 to both sides. And we end up with a is greater than 5. And then the other one, again, add 4 to both sides. And we get a is less than 1. And then graph it. So let's say 5 is here. My circle is open. my arrow goes to the right. The other one, let's say 1 is right here, my circle is open, my arrow goes to the left. So anywhere in either one of those arrows can be our solution. So A could be here, or here, or here, or here. It could be here, 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 and so on. The only place it couldn't be would be in this region right here. All right, next one. I'm going to divide both sides by 2. So x is less than or equal to 3, or divide both sides by 3. X is greater than 4. We graph it. Let's say 3 is here, 4 is here. Our circle will be closed. X is less than or equal to 3. Oops, I messed up. The circle is going to be open on the 4. It's okay to have one closed and one open. Now the first one is x is less than 3, so it's going to go that direction. Next one is x is greater than 4. It's going to go that direction. So again, your x's can be anywhere in either one of those arrows. X could be anywhere, and it keeps going that way. X can be anywhere here. It just cannot be here. All right, and then the very last part is where you're going to start with a graph, and you're going to have to write the compound inequality. Now A, notice the red arrows show you where the solutions can be. Since they're not overlapping regions, we know already that this is an OR. Now we just have to write the inequality. So let's just say it's x, and we've got our end point on the left is a -1. If you look, the dot is filled in, so it's going to be a less than or equal to, a greater than or equal to. And if you'll see where it's at, its x is always less than or equal to -1. And on the other side, again, the dot is filled in, so it's going to be either greater than or equal to, less than or equal to. And because the arrow is going to the right, then x is greater than or equal to 7. And then the next one, because we've got regions that are running into each other, we're going to say this is an AND. So we're going to put the x in the middle, and we're going to put the smaller number on the left, the bigger number on the right. The dot is filled in on the 0, so it's going to be a greater than or equal to 0. Or I guess if you read it from left to right, it would be less than or equal to 0 is less than or equal to x. And then x is less than 6, because the circle is open. And that is compound inequalities.
Made with Doodlecast Pro.